Problem 121 number 1. Find the displacement as a function of time given weight is equal to 4 pounds, k is equal to 20 pounds per foot, and your this y sub o here is 2 feet and v sub o is negative 8 feet per second. For a simple mass spring system, your differential equation is just like this: m times the second derivative of y with respect to time plus k times y is equal to 0. This is derived by Newton's second law. And again, your mass here is just equal to your 40 pound over your 32 foot per second squared. That is the acceleration due to gravity plus your value of k, which is 20 times y is equal to 0. And you can multiply both sides by the reciprocal of the coefficient of your y double prime, and you will get this y double prime plus 16y is equal to 0. And you can see here your characteristic equation is m squared plus 16 equals 0. This will give you the values of m, which is a complex roots, that is positive, negative 4i, and this will give you your complementary function y is equal to c1 cosine 4t plus c2 sine 4t. And you can solve for the constant c1 and c2, that is your initial length at t is equal to 0 is 2 feet, so you can plug in 2 feet here, and you can plug in time as 0. So 2 is equal to c1 cosine 0, which is just c1 plus c2 sine 0, which is 0. So this will give you the values of your the value of your c1, which is equal to 2. And then for finding c2, we use the second parameter v sub o, which is equal to negative 8 feet per second at t is equal to 0. So we can get the velocity when the function y is equal to c1 cosine 4t plus c2 sine 4t is being differentiated with respect to time. So it when we differentiate this function, it would look like this: dy over dt is equal to this function. And again, we can substitute, because this is now velocity, we can substitute negative 8 here, and for the time we can just simply plug in t as 0, and then it will gives us this value, and that is negative 4 c1 sine 0, which is already 0, plus 4 c2 cosine 0, which is equal to 1. So it will give you 4c sub 2 is equal to negative 8, and divide both sides by 4, c2 is equal to negative 2. So you have your two values of c1 and c2. You can plug it in your original function, which is your complete solution, which is this one, that is your y is equal to 2 cosine 4t minus 2 sine 4t.